Welcome back. I hope you had a wonderful weekend. Let's get started with our next chapter. Last time in chapter 3, we looked at the measures of central tendency. We looked at the mean, the median, and the mode. With these measures, we said we can use a single number to describe what is the average for, or the typical of the distribution. And while these are very helpful, they only tell us part of the story, because they only tell us the middle of the distribution. Another way to tell us even more is selecting a single number that describes how much variation and diversity there is in the distribution. And these are the measures of variability that we will be discussing here in chapter 4. After this chapter, you will be able to explain the purpose of measuring variability. You'll be able to calculate and interpret the index of qualitative variation, the range, the interquartile range, the variance, and the standard deviation, and you will be able to identify the strengths and the weaknesses of the measures. I want to begin by giving you an example of what variability means. So to give you a visual of what variability is. So let's say we are looking from the top down at a dinner party. In the middle of this party, George Clooney is standing. The yellow stars around him are his bodyguards. The red dots are some of his fans that were invited to the party, and the green dots are some of his close friends. So you can see that they are all spread out around him at various distances. And with the measures of variability, we can get a number that signifies how spread out each group is from Clooney, or how close they are to him, assuming he is the mean. Variability is defined as a quantitative distance measured based on the differences between scores. It describes the distance of the spread of the scores, or the distance of a score from the mean, and again in this case the mean would be Clooney, and how far are the bodyguards and the stars and his close friends away from him. Are they close? Are they cluttered around the mean, or are they farther away from him? So the purpose of measures of variability is to describe the distribution and to measure how well one individual score represents the entire distribution. Here's another visual example of variability. So here you can see the population distribution of adults for height and for weight. Let's just look at the first graph. You can see adult height is here measured in inches, and the mean height is 70. People obviously are not all 70 inches, so they differ, but you can see that it goes pretty much from 58 to 82 inches. So there are not too many people that are extremely short or extremely tall. And because of that, you see that most people don't differ that much from the 70 inches. So most of the scores are clustered around the mean. So you can see it's kind of a skinny graph. If you look at the second one, you can see they measured adult weight in pounds. And you can see here that 170 pounds is the mean. But there are a lot more people at the higher and at the lower end. So weighing all the way up to 230 pounds and all the way down to 110 pounds. So the scores are in pounds are a lot more spread out. So the measures of variability reveal the consistency or similarity of the scores in the distribution. And it shows us how much the average score truly represents all the scores in the distribution. So we can expect a much larger variation in the second graph because the scores are a lot more spread out away from the mean of 170 than they are in the first graph. And the mean and the standard deviation together provide extremely useful descriptive statistics for characterizing a distribution. So just these two values can tell us a lot about what our distribution looks like. So why is it important to know the variability? Well, let's look at this example. Here you can see the distribution for the final grades for Professor Brown and for Professor Yamato. You can see that both of the distributions have a mean of C+. However, both of them are shaped very, very differently. So which class would you sign up for? Professor Brown's or Professor Yamato's? Well, it kind of depends on what kind of student you are. If you are a straight A student and you really don't want to mess up your grade point average, you probably want to sign up for Professor Yamato's class, because here you can see the distribution ranges all the way from an A all the way to an F. So you do have a chance to get an F in his class, but you also have the chance to get an A, because he gives from A's to F's everything, even so the mean is a C+. Professor Brown's class looks very different. So let's just say you're somebody who just wants to get out of statistics, just be done with it, right? Then you don't really care about an A or your grade point average. You just want to get a passing grade. Then you might want to sign up for Professor Brown's class, because here you can see the grades range from a B to a C-. So the best grade you can get in his class is a B, but the worst one is a C-. And again, a C+ is the average of his scores. So the variability measure helps us to sum up the distribution of scores without looking at each and every score. Just the C+ in this case wouldn't tell us anything. But if we have the variability, we would find out that there's a lot more variability when we talk about Professor Yamato's class versus Professor Brown's class. We saw that the central tendency is a number that describes what is typical or average, so central in the distribution. The measure of variability are numbers that describe diversity or variability in the distribution. And this is important because the two types of measures, so central tendency and measures of variability, both of them together help us to sum up a distribution of scores without having to look at each and every score. Measures of central tendency tell you about the typical score, and measures of variation reveal how far from the typical or from the central score the distribution tends to vary. One way to describe how spread out the data set is by giving the range, which is just simply the difference between the highest score and the lowest score. It is used as a measure of variation in interval ratio variable, and it can also be calculated on percentages. Let's look at an example on the next slide. Assume we have a basketball basket competition, and in group 1, the lowest number of baskets one person made is 15, and the highest is 85. The range is 85 minus 15, the highest number minus the lowest number, right? So the range is 70 for group 1. But let's assume we have another group, group 2. They do the same thing, 5-minute competition. Here, the lowest number of baskets in the 5 minutes is 30, and the highest is 100. So you can see just by looking at the lowest and the highest that this group is obviously a lot better, right? Because even the lowest number of baskets was double what the first group made. But you can see if we take the range again, the highest minus the lowest, we also have 70. So you can see that while the range is helpful, the range doesn't really tell us anything about the individual values. In order to make up for these limitations of the range that I just showed you, we can use the interquartile range instead. The interquartile range is a measure of variation for, again, interval ratio or even ordinal variables. And it is measuring the width of the middle 50% of the distribution. So if you just look at these examples, the range versus the interquartile range, number of children among two groups of women. So in the first group, you can see we have 0, 1, 2, 3, number of children, and then 2 people actually had 10 children. In the second group, it's a little bit more spread out. Group 2 shows greater variability than Group 1. The range alone, taking the highest minus the lowest, is 10 for both, so it would not give us an accurate picture of what's really going on. And that is the importance of the interquartile range, because in Group 1 you can see the interquartile range is 2, while in the second one the interquartile range is 5. And you get that by just taking the difference between the lowest and the upper quartiles. So the interquartile range is Q3 minus Q1. The interquartile range is a measure of variation, like I said, for interval ratio data, and it indicates the width of the middle 50% of the distribution, and is defined as a difference between the lower and the upper quartile. So it's just Q3 minus Q1. And calculating it is really simple when we do a frequency distribution table. The first thing we have to do is find the 25th percentile, which is Q1, and then the 75th percentile, which is Q3. So let me give you an example. Let's just use the number of children for group 1 that we just saw, so I can show you an example of how to calculate the interquartile range. We said we have 0 to 10 number of children, and then in the second column here we have the frequency. So group 1 had 1 person had no children, 3 people had 1 children, and so on. We know we get the percentages by just taking the frequency over the number of people times 100. Well, we add the frequencies. We know we had 12 people that were asked, what's your number of children? And if we calculate the percentages for each, it is just 1 divided by 12 times 100. So we get 8.3% here, 25%, 25%, 25% for all of the 3s. And then 2 divided by 12 times 100 is 16.7. And remember, we had another column for cumulative percentage. And this one comes in handy when we look for the 25 percentile and 75 percentile. So cumulative percentage was just adding those up, and all of them together, remember, have to be 100. So 8.3 plus 25 is 33.3. Plus 25 is 58.3. Plus 25 is 83.3. Then we have zeros here, so it's 83.3 all the way here. Plus the 16.7 is 100%. If we are now interested in the 25th percentile, then where is that? The 25th percentile is within here. And then where's our 75th percentile? Well, that is right here. That's where our 75th percentile is. So our 25th percentile corresponds to 1, and our 75th percentile to 3. For that reason, it is 3 minus 1. So the interquartile range for group 1 is 2. The most common and most important measures of variability is the variance and the standard deviation. Both of these increase or decrease based on how closely the scores are clustered around the mean. So they both are measures of the standard or the average distance away from the mean. The variance is the average of the squared deviations from the mean of the distribution. It's a necessary companion concept to the standard deviation, but it's not the same concept. The standard deviation is the square root of the variance. I would like to explain the concept of deviation and variance first. Deviation is the distance from the mean for each of the scores. So the deviation score is then the score minus the mean. This way we see how far the score is away from the mean, right? We just subtract the two. So let's say this is our data set. We have the scores of 8, 1, 3, and 0. So first, in order to see how far each of these values is away from the mean, we have to get the mean. Well, we know the mean is just the sum of the scores divided by the total number of people. So the sum of the scores here is 12. We have 4 people, so divided by 4, so we get a mean of 3. Let's see how far each of these scores is away from 3. Score minus the mean is 8 minus 3, so the first one is 5 away from the mean. The second one, negative 2, then 0, so it's exactly the same as the mean, and then negative 3. The problem is that if we would sum these deviations up, we always will have 0. So if you add 5 plus negative 2 plus 0 plus negative 3, you're going to see that we're going to have 0. Since the sum of deviations is always 0, and if the sum is always 0, then the mean deviations must also be 0, so it doesn't really help us to find the deviation. For this reason, we are squaring each of the values. As I just noted, the problem with averaging the deviation scores is that some have positive and some have negative values. And these, again, always cancel each other out. So the solution is to get rid of the positive and negative signs. And the easiest way you know how to do this is by squaring the values. Because remember, if you square a positive value, you'll end up with a positive value. But if you square a negative value, you're also going to end up with a positive value. And that really solves our problem. So we're just adding another column and we're squaring each of these values. So 5 squared is 25, negative 4 squared is 4, 0 squared is 0, and negative 3 is 9. So now when we add these up, we have the sum of the squared deviations. In this case, this is 38. And that's all we need to get our variance. because the variance is just the average squared distance from the mean. So the formula, the sum of our squared deviations over n minus 1. And this is the symbol for the variance. And at this point we are golden because remember the standard deviation equals the square root of the variance. So once you calculated the variance, all you have to do is take the square root out of it, because here you see this is exactly the same formula as the variance. We just take the square root, and then we have our standard deviation, which gives us the measure of variation for the interval ratio variables. And the reason why we do that is, since we squared the values before, the variability is now measured in squared units. But in order to get it back to the original units that we had before, we need to just take the square root. So let's just practice. So let's apply it. For the following sample of n equals 7 scores, we want to get the variance and we want to get the standard deviation. So we have 7 people in our sample, and these are the individual scores. So again, we start by writing down what it is we know. These are our scores, and we know we're looking for the variance. So we write the variance formula down. Here we see that we are going to need the mean. So let's get the mean first, right? We need to get the mean. And we need to get the sum of each of the scores minus the mean squared. So let's get the mean first. We know the mean is the sum of y over n. The sum of y is 35. We have 7 people, so our mean is 5. Now let's look inside the formula. It's asking us to subtract the mean from each of the scores and then square it and then sum it up. But let's do that first. We're adding another column. So this is the score minus the mean. 8 minus 5, 6 minus 5, 5 minus 5, and so on. Right? These are the differences. But remember, if we would add them up, we would get 0. So we have to add another column, and we square each of the values in order to get the sum of this. In this case, that's 24. Then we plug in 24 over 7 minus 1, so we get a variance of 4. And remember, once you have the variance, all you have to do is take the square root of that in order to get the standard deviation. So this is a formula for the standard deviation. Taking the square root of the variance, square root of 4 equals 2. The key terms in the formulas for this chapter are the interquartile range, that it's called the measures of variability, so the range, the variance, and the standard deviation. And then the important formulas are the formula for the variance and the formula for the standard deviation. And the range was simple. It was just the highest minus the lowest score. Congratulations, you reached the end of this chapter. Remember, if you have any questions, please email me anytime. Bye. See you next time.